Hello everyone. Today we'll be talking about how to import and export your datasets from R. So before we get into actually importing the data, let's talk a little bit about how to get organized to make your R code and datasets much easier to use in the future. So every time I start a new R script or a new R project, I create a folder for that project. So we'll just call this importing data tutorial. And I'm just creating it on my desktop, but obviously you would create this anywhere that it was handy to keep track of your R scripts. And then inside of a folder, I always create two other folders, one called inputs and one called outputs. And the way I organize this, of course, is I put any data that's going to be pulled into the script in the inputs folder, and anything that the script creates, any sort of files, whether they be images or new data sets, are going to go into the outputs folder. And in the outputs or the inputs folder, you can create subdirectories as needed. In this folder here, in the importing data tutorial folder, I'll save any R code. So when I open a folder for a project, I'll have a folder with all of my code, and I'll know where all of my inputs are and where all my outputs are. It's also useful if in your inputs folder you create a text file or a Word document or whatever where you describe where all of your input data is coming from. Now we're not going to do that today because I'm just generating some nonsense data on the spot. But if you do create a script and use some data and then come back 6 months from now, it's very helpful to know which maybe website you downloaded that data from, what version that data is, what's in the file if you don't remember, and what date you downloaded it on, so that if you end up moving the outputs of the script into a paper at some point to publish, you can very easily go back and say, this is where I got all of the data that was used for this analysis. Okay, so in our case, for the inputs folder, we're going to put just some example data sets that I've created. And it's really just the same data set 3 times saved in 3 different ways. So the first is just an Excel spreadsheet. And here we can see that it's a very small data set with 3 columns. It has a name column with several different individuals. It has a favorite color column, and I've put a number at the beginning here just to show you that sometimes numbers at the beginning of a column name can be problematic. And then I have a favorite number column, and also to show you that special symbols can be problematic, I put a % sign at the end of this. So this file is an Excel file, .xlsx. I've also saved the file in a tab delimited form, so I'm going to open this up with my favorite text editor, which is Notepad++. And what you can see here is now it's just a text file, and these yellow arrows indicate a tab. So between each column, there is now a tab, and this is a very common way to store matrices and tabular data in text format, is to have it be tab delimited. Another very common way is to have it be comma delimited. So that's going to be comma separated values.csv file, which will also open up in Notepad++. And you'll see that it's exactly the same as the tab delimited, except instead of a tab between columns, there is now a comma between columns. As you can imagine, both of these formats can run into problems if you have tabs or commas, within the data for a given column. Often that is going to be handled by having double quotes around all of the values. So instead of name, comma, it would be quote, name, quote, favorite color, etc., with the comma, again, separating the columns. Okay, we don't need that for now. So let's not save the changes, and let's talk about how to import these data sets into R. So we'll open up our R terminal. If you're using RStudio, you'll notice that you have an Import Dataset button here. So we'll use this, but we'll talk about how to actually just write it as code too. But you can just use the menu. So first, let's import from Excel. So we'll click the From Excel button. We'll browse to the location of our folder, in this case, desktop. Importing data tutorial inputs and .xlsx. Okay, so this is giving us a preview of what the data will look like, and as you can see, everything looks as one would expect. note that there are some options down here that you can change. So right now it's going to open the data viewer after we import the file. If you have a really large file that you're importing, that might not be desirable, so you could uncheck that. And you'll see it's giving us a code preview, so it's telling us what code it's actually going to execute to do this import. You'll also notice that it's currently taking the first row's names, which is what we want because we do have column names in our file. But if we didn't have column names, we could import it without column names, and it would just create dummy column names for us and have everything as data. But we do want that. We are going to take all of the rows. We're not going to skip any rows. If you had multiple sheets in your Excel file, you could tell it which sheet you wanted to import. And this here is just telling us what the name of the R object is going to be that we're creating to hold this data. Example data is just fine. So we'll click Import. And you'll see down here in the console, it ran this code. If you are writing an R script that is more than just you spending a few minutes to check something manually and you never plan to do it again, you really want to go ahead and copy this code into an R script. And that way, if you come back and redo the analysis, you'll be able to import the data automatically instead of having to go through and click the Import Dataset button. Okay, so let's look at the data. It looks fine. It looks good. One thing to note, it's problematic to have a number at the front. With importing an Excel file, it kept that number, but if you want to do a $sign to pull out that column, if you select it, you'll note that R has to put it in these single quotes. This isn't actually an apostrophe, it's something else. I'm not quite sure the name of that character, but it has to be marked specially to handle the fact that this is a number. You will also have to put any column names in these quotes if you have spaces in your text. So that's just something to note. I think even special characters, so if I just do favorite number, yes, because you have this %sign, it also has to do the special quotes. Notice if you just do the normal all text column, there's no need for the quotes. That works just fine. Okay, so that's one thing to note, but at least if you import it from an Excel file using the package that clicking this button uses, which is the readxl package, so notice it loaded a library first, and then it imported the data using a function that is from the readxl package. If you do that, then it will keep numbers and special characters in your column names as they are in the spreadsheet that you imported it from. Okay, so let's talk about importing the text file. So you'll notice there's a base and a reader option here. So base is just going to use the functions that natively come with R to import text data, and reader is a package that allows you to do the same thing, but maybe slightly more efficiently. Really, it doesn't matter which you choose for a data set this small, but if you're importing really large data sets, the reader package is going to be a little more useful. It gives you a progress bar, and it tends to be a little faster. So we'll just use the reader package for now, since that's often what I end up using anyway. Go to Desktop, go to Importing Data Tutorial Inputs, and in our case, we can do either the text or the CSV. We'll do the text first. And we'll see that in our preview, things don't look right. So it's combined everything into a single column, and the reason is it has the wrong delimiter. So delimiter is the character being used to separate columns. And in this case, this is not a comma-separated table. It is a tab-separated table. So if we click Tab in the delimiter, now we get the correct output that we want, and we'll see that it has added this /t. /t is the way you indicate a tab, and we'll talk a little bit more about that after we do it. So we're going to example data, and this is tab delimited, so _tbd I'm going to put there. We'll import, and we'll see that it has now loaded another library called reader. As we said, that's the package it's using here, and this is the code that it ran to import the file. So let's talk a little bit about what happens if you use the base package instead, because it is slightly different. So we're going to use import from text base. We'll go here, example data text. You'll notice that this one did automatically detect that we're going to use a tab. Strings as factors generally keep as false. There are no double quotes, but it doesn't actually matter. It doesn't hurt to have it selected here. We do have headings. So note right now this is our preview of what it's going to look like. It's creating its own column names because it doesn't think we have headings, but we do. So we'll click that. And notice when we do that, it's now getting rid of this number 1 at the front, and it's getting rid of this %. So the base package or the base functions for importing text data try to avoid needing to use those quotes. So it's going to put an X in front of any numbers that start something, and it's going to replace any special characters that don't work without the quotes with a period. So we'll import this. This is going to be tab D base. You'll notice that this time it again changed the columns, but it also didn't load a package because it didn't have to. The read.delim function comes natively with R. And notice that now where we do example data tbd base, we can do this without any quotes. It removed any special characters or problems that would require us to quote the column names. Okay, so those are some differences. For comma-separated values, it's very much the same. So if we want to import text from either the base or reader, it doesn't matter really. We'll go here. We'll go importing data inputs and CSV. And it's going to be comma-separated. That's all going to work fine. We'll do CSV. Import. Here's our call to the function to import the data. And it looks pretty normal. So one thing I do want to compare and contrast. So these are, so note that for the read CSV, there's a read CSV function, and basically it's the same thing as the read delim function. So these are both using the reader package, these two calls on lines 9 and 10. But the read CSV basically defaults the delimiter to a comma instead of a /t. So really, you could also write this. If we just take this, oh, I did it wrong. Okay, CSV. So if we're loading the CSV file, we could also use this read delim function, and then instead of having the /t here, we would do a comma here. And that would also load the data correctly. So example data dot CSV, you'll see that that works just fine as well. That delimiter is just an option to specify what's being used to separate columns. Okay, so we've loaded these data sets now several different ways. Our code is looking a bit messy, and also every time I went here to select things, I had to manually go, navigate all the way to the folder where the data is being stored, and note that we're having to use full paths all the way from C user. So in case you're not familiar with Windows, C is basically the drive letter. It's where you start navigating from. So we're doing a full navigation path all the way to our data. This is fine unless you move the folder the data is stored in and your code is stored in later because you're reorganizing things. If you try to come back and rerun the code, all of this part of the path will now be incorrect, and your code won't run correctly. So if you want to be able to move your code around, it's nice to do something called setting a working directory. So to do that, we're first going to save our R script. So in this case, we'll go to importing data tutorial, and we'll just name our R script importing tutorial. Okay, and then let's go to session and go to set working directory and to source file location. And what that does is it runs a command that's set working directory. That's what setwd stands for. And then it has the file path to your working directory. A working directory is just the folder that R starts looking in when you're looking for files to import or export. So to keep our code organized, what you always want to do at the top of your script is just put setting working directory and then I like to do a libraries bit of code where I put all of the libraries I'm going to load in for this script so that it's easy to see which libraries are required. And then I like to have an importing data, and I can subdivide this as needed. And you'll notice I'm tabbing things over just to make it very easy to read through the code and see which section each bit of code belongs to. Okay. So now that we have this set working directory, we don't actually need this full file path because R knows that this should be at the beginning of everything if we just put a dot there. Dot means current directory if you're used to working maybe in a Linux file folder environment. You do dot, and then that indicates your current directory, and then everything after that is navigating to new directories. So here we can do this. For all of these, make sure I get it right. And we'll just clear our environment so that you guys can see that indeed this does load everything just fine now with these shorter file paths. Now the advantage to this, as I said, is now you can move your data more easily. So let's say, well, let's just minimize this. Let's say I've moved this folder or it got renamed or whatever, and now it's just importing data. And I have to close something first. It doesn't like something that I have open. So let's just close this. R saves a workspace in the background, which was the problem. It had this R history being written to, and it wouldn't let me rename. Okay, anyway, now it's renamed. Let's open up our R script. It's telling me that my original .r file has been moved or deleted, and it's asking me if I want to close it, so we'll say yes. And let's just close all of these tabs. So now we have our script. We're setting our working directory, and it's going to tell us, oh, that working directory doesn't exist because we got rid of the importing data tutorial folder and changed it to the importing data folder. But to make the whole script work again, all I have to do is put the correct working path now, the working directory, and now I can import all of my data just fine and the whole script will run. So the advantage of having a working directory here is if we didn't do this and we moved all of our data or our folder or whatever, to get the script to work again, we would have to go down and modify each of these paths individually. But since we have a working directory, we only have to modify it right at the top of the script here and everything will run fine. So I do recommend using a working directory at all times when writing R scripts. Okay, so we are now we've now successfully imported data. Let's make things a little bit simpler. We can just use the XLSX version of the data, the Excel version, so we'll just comment this code out, import this data. Let's talk about what happens if we want to save data now. So this is just a data frame. It got imported as a data frame with 3 columns. So there are a few ways to save data. So let's first save data in a tab delimited format, which is very similar to what you would do if you were saving data in a comma delimited format. So for this, we're going to do write dot, well, we'll do write underscore delim here. I sometimes mix up the various commands between base and reader because you use reader so often. So I'm just going to do write underscore delim. So we'll just pull up the help file for that function, write underscore delim. And you'll see this is to write a data frame to a delimited file. We have a data frame, so that's excellent. You could do it with a matrix as well, I believe. X is the first argument, and it is a data frame or tibble, which is a data frame-like object that's used by certain packages. But it's a data frame to write to disk. Okay, so X equals example data. And the file or connection to write to is just the file path that we need. So here we're going to do dot to indicate our current directory /outputs. slash example data dot text, and I believe with this version of the function we also have, okay, we don't have sep, instead we have delim, so we're going to do delim, which you'll notice defaults here to a space, so it would do space delimited. I prefer tab delimited, so for that, again, it's \t to indicate tab delimited. And if we run this bit of code, we can go to our folder where things are organized, and we'll see that in outputs we now have example data that we have saved, and it is tab delimited, and everything looks correct. Okay. You could do a comma delimited version of this very simply by changing the /t to a comma, and let's change our file name as well. And now we can see that our outputs have a .csv version of the file here. But what if we want an Excel version of the file? Oops, it's not closed. Okay, so for that, we need a different package actually. So for that, we're going to do library, and I like the Open XLSX package for doing this, and I actually use the Open XLSX package for loading my R data most of the time. I didn't show that because most of you will probably find it easier to remember things by going to this button, or going to this menu and clicking from Excel to remind you what the command is. But with the Open XLSX package, we can now write .xlsx, and it's very similar. So we're just going to do the name of our data, and we're going to do .outputs / example data .csv .xlsx, sorry. And now when we write this, we will have created an Excel version of the file in the outputs folder. Okay, so that's great and all, but what if you have a list? How can you save a more complex, n-dimensional object in any format that you can use later on? So it really depends on the type of list that you have. If you have a list of two-dimensional or one-dimensional objects, then you can save them to an Excel spreadsheet with multiple sheets, and you could do this. So let's just make example list, and our list will just be repetitions of the example data frame. So temp list is going to be list example data, and then we'll do example data again. So now we have a list of two objects. Both of them are the same, but they're both just, in this case, a tibble, but they're really a data frame. I guess I should mention, I don't like tibbles. I've never found a good use for them. They occasionally break code. So if you ever have a situation where you really need data frames, you can wrap your load function in as.data frame, and example data will now be a data frame instead of a tibble. I really prefer that, but other people like tibbles. They behave mostly the same, but sometimes tibbles break code. Okay, so regardless, we now have a list of two data frames. If we want to name our list, let's name one A and one B. These will now become the names of the sheets that we write here. So let's do write.xlsx, and this is now going to be temp list that we are saving. We'll do temp list.xlsx. So if we go and look at that file, we'll see that we have now saved a Excel spreadsheet with two tabs. They're the same, A and B, but this allows us to save a list of one or two dimensional objects into an Excel spreadsheet. That's great, but what if you have a more complex list? So let's say temp list is now list of temp list and temp list. So this now gets a little bit confusing. You'll see it now is a list of two elements, and each of those elements is a list of two elements. So this, as you can imagine, isn't convertible to an Excel spreadsheet particularly easily. If we go look at here, and we look at templist xlsx. It just sort of merges and mashes things together and gets a bit messy. I would say it'd be very hard to re-import this data into R in the same format that it currently exists. So what if you want to be able to re-import data into R in the way that it currently exists exactly? The best way to do that is to save it as an R data storage object. So for that, we're going to use the function save RDS, and we can do our object and then our outputs, templist.rds. So now we have, keep closing that folder. Wrong outputs. Now we have an RDS file which we can load into R. I'll just name it temp. You'll notice it runs the read RDS function and imports the data exactly as it was originally. So to summarize, you can save data, save in delimited format, tab or comma. You can save Excel format. I tend to use the Open XLSX package for that. Or if you really want to be sure that you can re-import the data into R in a different script later on, or maybe the same script if you want to pick up where you left off, I highly suggest saving in an RDS object. And if we just look at this save RDS function, I can't remember exactly if it's with this function or if there's a different function used, but you can save multiple R objects into a single .rds file. And why don't I pause the video for just a second, and I'll come back and let you know the answer to that. All right, so I've looked it up. With save RDS, you're saving a single object. So object as RDS object, and you can load with, is it load RDS or read RDS? It is read RDS. Okay, so if you want to load your RDS objects, you'll use this function, the read RDS function. If you want to save multiple objects, as an R data object, you're just going to use the function save. And here, if we want to save example, data, and temp, we'll just put those both in, and then we have to specify the file we're going to, so we'll do ./outputs, and we'll do temp.rData. We'll run that. And if we go to our outputs folder, we'll now have a temp.rData file, which we can load with just the load function. Actually load, and we just need the name, so /output/temp.rData. And that would load these objects back in if they had been removed. I can show that just by doing rm temp. So that removes the temp object, and if I load it, you'll see that that has been restored. If you want to save your entire workspace, you can just do save.image. And I believe with this we can probably specify a file. Yep, so file equals .outputs.full-image.rData. And there, we'll see that we now have our full image. If we wanted to load all of our objects back in, again, we could just use the load function. full-image.rData, and we will have reloaded all of our objects. Okay, so hopefully this has helped you learn how to import data from different file types into R and the various ways that you can then save that work if you want. I'll put this script a link to this script in the video description so that you can look back through these functions if you want. But again, if you forget and have no idea what to do, a good place to start is by clicking the Import Dataset menu.